Good morning. Am I audible to you? So when is the Pongal? 13, 14, 15, 16, 17 also. Hmm. What is exactly Pongal day? 13 and 13 Saturday, 14 Sunday, 15th. Pongal 15th. Pakka. Pongal 15th. 14th. So you don't know when it is. I am asking only Pongal day. I know festival is 3 days. I know that. Exact tell me one day. Acha. Monday, that's why you are saying 15, 15, 15. अरे क्या holidays रे? Holidays are over. No holidays. No holidays. Assumptions in linear regression. What you will do in holidays? Celebrating festival. Eating. My father called me yesterday. He wants to do some festival on Sunday. He is inviting. Hey, I will not come. I will not come. I said. My brother also said same thing. Will not come. So whenever you age will grow, you have family, you have so many constraints, narration, office work, blah blah blah, so many things. You can't encourage other things. Going home, celebrating something, you can't encourage that. So your life grows, your circle will be small. You will be in that circle only. If you want to come out of that circle, then you're gone. That is the things. So enjoy nowadays only when you are in young before marriage and all these constraints. After marriage also you can enjoy if you don't have any constraints, like me. That is, when you have a constraints are there, then that is difficult. If I want to take 1 day holiday for at least Naresh IT, then so many will suffer, no? That is, you will happy, I know that. That is, if I want to take the off from the office also, again, there also people will suffer. That is, so many constraints. Chalo. Assumptions in linear regression. Then my mother will call in the evening. So I put my father, right? My father will go to complain to my mother. Then my mother will call. Father will not scold. Mother will scold a lot, right? Why you are not coming? Why you are doing itna build up? Come like that, blah blah. And mothers will say that extra word. Is everything saying by your wife or what? Mother will say one more extra word. So first assumption is linearity between independent and dependent variables. It is very, very important. It is very important to check the linear condition, linear condition before applying linear regression. It is very important to check the linear condition before applying the linear regression. Linearity check, that is called. So scatter plots are best example, ma. Scatter plots will give the idea. Will give that whether they both are in linear relation each other or not. Linear together or non-linear. Scatter plots will give that linear observation. Scatter plots. You know, right? Scatter plots. That is, so scatter plots is the example. You need to explain the assumption as well as how can you find that also. You need to explain that is scatter plots. That is very simple. That is the scatter plots. You can get that. And second one is multicollinearity. There is no multicollinearity between the variables. This is a very, very important assumption. And people will discuss about this. There is no multicollinearity between the variables, which means there is no relation. There is no relation between the variables. Multicollinearity is a term related to correlation terminology. So multicollinearity is nothing but correlation kind of thing. There should be no relation between the variables. Dependent variables. Sorry, independent variables. Input variables. Input variables. There should be no relation between the independent variables. Independent or input both are same. Multicollinearity. What happens if you have multicollinearity is there? Suppose, think like that, you have a data is like this is there. You have a data like this is there. TV and newspaper and sales are like this is there. And TV is equal to 100 is there. Newspaper is equal to 200 and sales is equal to suppose 2000 is there. And this is the 200 is there and this is 400 is there. And this is equal to 3000 is there. And this is equal to 300 is there. It is 900 is there. It is suppose 6000 is there. Now, if you, this sales is nothing but a sales is here is which variable? Output variable. TV and newspaper is which variable? Input variable. Now, what is the relation between the TV and newspaper specifically here? Newspaper equal to newspaper equal to TV, suppose we'll write 600 here, okay? 2 into TV. What happened 2 into TV? What happened 2 into TV, correct? Now, write the linear regression equation. Y is equal to beta naught plus beta 1 into TV plus beta 2 into newspaper. Now, instead of newspaper, substitute this 2 into TV. Substitute this 2 into TV. Beta naught plus beta 1 into TV plus beta 2 into 2 into TV. 2 into TV. Now what happened now? Here y equal to beta naught plus beta 1 into TV. And if you TV common, if you put TV common, what will be there? Beta 1 plus 2 into beta 2. Correct? 2 into beta 2. Now beta 1 plus 2 into beta 2 equal to, if you equate equal to 0. Now this, how many unknown variables are there? Two unknown variables are there, B1 and B2. If you want to solve two unknown variables, how many equations are required? Two equal, but how many equations are there? One equation, two unknown variables. It is not converged in the mathematics. Okay. So one equation we have, but two unknown parameters. Two unknown parameters are there. So the equation never be converged. The equation never converge. So what is mean by converge here? Which means the beta 1 can be any value and beta 2 can be any value. Beta 1 can be any value and beta 2 can be any value. That is the meaning here. So because you take here, what you will take, I will remember in you people are cheating. Beta 1 and beta 2. In the mathematics, in the BTech, we have done this kind of thing, right? Convergence, non-convergence will take beta 2 equal to K. Then beta 1 will become what happened now. So let us assume beta 1 equal to K in that equation. Beta 1 equal to K. Then what is the beta 2 equal to? Beta 2 equal to minus K by 2. Minus K by 2. So K and minus K by 2. This kind of equations we have done in the eigenvalues and eigenvector concept. Remember that? At least thoda. K and K by 2. Okay, forget about that. At least do you know this? One equation we have but two unknown parameters, the equation never be converged. Which one? No, this is, I am taking, suppose this is the equation. Okay, this is the equation. Equation means always equal to what? 0. That's the equation. I am taking this a kind of a equation. This equation is never be converged. This equation never be converged. And this is the one reason why we need to avoid the multicollinearity. That is the one mathematical reason this is. This is the one mathematical reason you need to explain in that why multicollinearity you need to avoid between the. That means if two variables are related to each other, that is a problem. That is a problem. Understood? So this is the mathematical way. And one more thing, if you want to say theoretical, if both are related to each other, why you want to keep two variables? One variable is enough, right, to keep. That's the next question you will ask me, right? I'm using two variable TV and newspaper. And then you will ask me the question, you said both are related to each other. Then why two persons are required? Only one person is enough. If two persons are doing same work, why I will require two persons? One person is enough, no? I will not pay to another person. That question you will ask. Then next question is what? Which one you want to keep? TV or newspaper? Which one you want to keep? How can you decide that? How can you decide that? No, that is the problem. That's why you need to avoid the multicollinearity. That is the problem. Understand now? That is theoretically you can say. Theoretically, what you can say that if both variables are dependent each other, have relation or having relation, then the question is why we need that, why we need to include two variables. We can include only one variable. We can include only one variable. But what is that variable? The question is which one? Which one? That is the question. So this is theoretically you can say in the interview. Definitely he will ask you why multicollinearity is a problem. Definitely he will ask you why multicollinearity is a problem. Then you need to explain this as the theoretically and this you need to explain the mathematically. If you explain this, interviewer will be very happy. That means you are connecting the mathematical dots. Getting my point? So that's why you try to explain this. This is the important one. One equation, we have two unknown parameters are there, equation never be converge. So it is a problem by using mathematical way. And theoretically, you can say that both variables are having relation. Then why we need to include two variables? We can include only one variable, but which one? We can't be justification. We can't do the justification. One more third way is standard error formula. What is the standard error formula? Sigma by root over n. Standard error formula equal to, I'll give three reasons now. Okay. But only one reason only will be in the textbook. I found this is one textbook and above one is another textbook. That is okay. Two textbooks I given two reasons. I like this reason only because generally I like mathematics. So I like this reason. But this reason is also they given. Standard error. Now you said that for suppose the both variables are related each other, the n become what happen, the number of observations will be what happen. Suppose the one observation here is the 10 is there, here one observation what happen, 20 will be there. Assume that. Here one observation value is equal 30 or 40. So what they are doing is they are getting somehow instead of n, they have in the relation that means that might be a 2n kind of thing. They are getting like this kind of thing. 2n. So n observations having the relation, that means the values are might be same, right? N observations, first observation, second observation, third observation, the value n equal to 10, another value equal to what happened? 20. So that means they are the relation, right? That is that they have a relation like this. See, 100, 200, 200, 400, 300, 600. So n become what happened now? 2n. Now same, now if you modify this the same thing now, it become what happened? It becomes standard error. The new standard error will be standard error by root over 2. Standard error by root over 2. That is the same thing. The same thing. Standard error by root over 2. That means what they are saying is the standard error will be decreased by root 2 times. If the two variables, if the two variables, if the two variables have multicollinearity, then standard error decrease standard error decrease by root 2 times. How many times? Root 2 times. Root 2 times. When standard error decrease, what can be affected by standard error? Tell me. Standard error affects the it affects the t value. It affects what? Which value? T value. What is the t formula? Z formula. T or Z value in your language. T value or Z value. Yesterday we discussed, right? T value or Z value. When Z value affects, it affects which one? P value. P value affects which one? Your conclusion. So all are interlinked. So standard error changes. What will change? T value will change. T value changes. P value changes. P value changes. Conclusion will be change. This is the one of the nice explanation they provided. Okay. These all are interlinked. If standard error changes, your confidence interval also will decrease. Confidence interval. Have you remember the formula? Point estimates plus or minus standard error into something. So standard error changes, everything will change. Everything will be changed. If two variables have multicollinearity, standard error will be decreased by how many times? Root 2 times. Standard error affects t value or z value, and that affects p value, and that affects the conclusion. That is. So that's why you need to avoid the multicollinearity. Avoid the multicollinearity. The next question is how to avoid the multicollinearity. How to avoid the multicollinearity. To avoid the multicollinearity, you need to identify which variable causes the multicollinearity. Which variable causes the multicollinearity. To avoid that, to avoid the multicollinearity, we need to identify which variable causes multicollinearity. And then the concept is called very, very important interview question, VIF. Variance inflation factor. Variance inflation factor. Variance inflation factor. VIF. So VIF is equal to 1 by 1 minus R square is the formula. 1 by 1 minus R square. Variance inflation factor. variance inflation factor. To avoid the multicollinearity, we need to identify which variables are causes multicollinearity. How to find that? What is the technique is called? Variance inflation factor. So variance inflation factor, what is the formula? 1 by 1 minus r square. You need to identify the r square. Now that r square, you know, it is the equation like this. Suppose think like that. The equation is like this: y equal to beta naught plus beta 1 into TV plus beta 2 into social media plus beta 3 into newspaper. This is the equation. Think like this. You know, for this equation, what you will get? R square you will get. That R square, not that R square. For this R square, what is your output? Y. What is your output? Y. The new R square you need to find like this. See, very, very carefully. You need to take only, what are the variables are there here? Input variables. What are the input variables? Input variables are TV, social media, and newspaper. So the first equation will be like this. The first equation will be TV equal to beta 1, same thing, same equation, beta naught plus beta 1 into social media plus beta 2 into newspaper. This will give 1 r square. Yes or no? This will give 1 r square. Every regression equation will give 1 r square. What is the meaning of this r square? How social media, newspaper, how much they are explain about TV. That is the meaning, correct? So you need to write like this. First, you need to implement only social media. This is the r square 1. This is r square 1. Assume that this is r square 1. What is the r square will tell? Tell me. The percentage in variation in TV explained by social media. That is the meaning, correct? That is the r square 1 meaning. Similarly, you will find the r square 2. What is r square 2? Similarly, you will find what? R square 2. TV equal to next beta 2 into newspaper. Now r square 2. R square 2. The percentage in variance explained by social media and newspaper. Explained social media and newspaper. This is r square 2. Now, like this, you need to find the r square. That means your interest is you want to find the relation between the social media and newspaper and TV, right? Input variables relation, not with output. So this is a equation, okay? This is a equation, but this equation is what? Independent and dependent equation. But here we are concentrating only on the input variables. That's why what we are keeping TV as one output and remaining what else? Input. It is also will give 1 r square. It is also will give r square. This r square will explain about your model explainability. This r square will explain about what? Model explainability. Same concept only. What is the concept here? TV and social media and newspaper together are explained about what? Why? Similarly, social media explained about what? TV. Here, social media newspaper explained about what? TV. Now, you will calculate here VIF also. What is the VIF formula? Now, VIF formula here. Now, VIF formula, suppose this r square is equal to 80. Assume that this r square is equal to how much? R square 1 here. R square 1. This r square 1 is equal to 80. So 1 by 1 minus 0.8. 1 minus 0.8. Now how much 1 minus 0.8? Tell me what is the final answer? 1 by 0.2. 0.2. Then what is the answer here? 5. That is the 5. That is the 5. So in industry, VIF cutoff is, the cutoff of VI is 10. The VIF cutoff is how much? 10. If anything, if you find anything is greater than 10, then that both are relation in each other. That is causing a multicollinearity. Now here these both are not causing multicollinearity. TV and social media not causing a multicollinearity. How much value? 5. Suppose you are getting this 0.9. 0.9 you are getting. Then what is the 0.9 here? 0.1. 0.1 means how much? 10. Then these both are in multicollinearity. Then these both are in multicollinearity. That is explained by VIF. Understood? VIF means very simple. VIF is nothing but variance inflation factor, and the formula is what? 1 by 1 minus r square. So you need to find the r square value. So every regression equation will give the r square value, that we know. But here we will concentrate only on the input columns. We'll concentrate only on the input columns. So TV equal to beta naught plus beta 1 social media. We will create a regression equation. We'll create a regression equation, and this equation will give one r square value. What is the meaning of r square value here? How much variation in TV is explained by social media. That is the definition, correct? Now, suppose this r square is coming 90, means 90% variation in TV is explained by social media, means they both are stick together or not stick together? Definitely stick together. That is my common sense is saying. And that is only VIF also is saying. What is the VIF? 1 by 1 minus r square 90%. That means 1 by 0.1. How much is the 10? 10 is the answer. If 10 is your manager cutoff, then you can conclude that these both are in multicollinearity. These both are in multicollinearity. So you should avoid. You should avoid one of the variable. That is again the discussion. In this way, we will find the multicollinearity. Any doubts in this? Can you please confirm the chat? VIF is very, very important, ma. Organized to organization. VIF cutoffs. Multicollinearity. They are saying that 5 to 10. Multicollinearity presented when VIF is higher than 5 to 10, or the condition is higher than 10 to 30. That is multicollinearity. VIF is a very, very important pakka question. First of all, assumptions in the question. Definitely you will say there is no multicollinearity. Then what is the question he will ask? VIF only. Think like an interviewer perspective. You are the interviewer. Then understand which question they will ask you. Concentrate only on that question. VIF is the pakka question. Okay. I asked one guy in the recent time interviews. He explained everything correct, but he forget about the answer for formula. He forget the formula. 1 by 1 minus r square is the formula. He forget it. But he explained everything. How to do this, everything he explained. He told me that take the input variables. Every time keep one of the variable as the output and remaining variables as the input. Find the r square. And wherever the VIF is coming, you can calculate the VIF. He explained everything is same. Then I asked what is the cutoff of VIF that is. He said that 5, 10, 15, 20, he said. I will get that value, I said. By using r square, he said. Then what is the formula? I asked him. He forgot the formula. Everything he said. That is. So every time you need to keep one as what? Output variable, and remaining are input variable. You need to keep like that. We will not concentrate on this. Again, you solve like this, you will get the values beta 1 also. Different, right? Definitely. Because your explainability on what now only? This. It is a different equation. It is a different equation. It is a complete different equation. It is a complete different equation. This beta naught beta 1 different. This beta naught beta 1 is different. Because the generic equation. These values are different and these values are different. Definitely these values will be also different. Understood? VF means, can you please confirm the chat? Will you able to explain in the VF needs to be 0. If you want VF needs to be 0, what is that? When you will get 0? When you will get 0 VF? Let's discuss about that. When VF will be 0? Numerator will be 0. R square value 0 है तो क्या होता? 1 होता ना? हाँ. When will be VF will be 0? Then what is the minimum value of VIF? 1. That's it. Minimum value of VIF is 1. What is the maximum value of VIF? R square maximum value कितना? 100. 1 by 1 minus 1 कितना? Infinite. So VIF minimum value equal to 0, maximum value equal to infinite. Note down that. VIF minimum value equal to 0, maximum value equal to infinite. Same way. R square minimum value is equal to how much? 0. Maximum value is equal to how much? 1. Same way. Adjusted R square. 1, no? 1, right. Adjusted R square. Minimum value equal to maximum value equal to R square. Note on this. VF minimum equal to 1, maximum equal to infinity, R square minimum equal to 0, maximum equal to 1, adjust R square minimum equal to 0, maximum equal to R square. So multicollinearity is related to VIF. That combination you need to remember. Okay. Next one is now third assumption. Third assumption is related to errors. Related to error. Errors are no autocorrelated. Errors are no autocorrelated. Errors are no autocorrelated. Or there is no autocorrelation in the errors. There should be no autocorrelation in errors. There is no autocorrelation. What is my autocorrelation? What is covariance? What is variance? What is autocovariance? What is meant by biography and autobiography? हाँ खुद के लिए लिखते तो ऑटोबायोग्राफी आता. Then what is autocorrelation? What is autocorrelation? The relation between the two variables are there, x and y. The relation between two variables, what we can say that? Correlation. If relation x itself, autocorrelation. That's it. That is called autocorrelation. Autocorrelation means खुद के लिए relation. That means a share market 12 months back, how that related and now how that it is related now. Now, x is there, y is there, and y prediction is there. Y prediction is there. Y prediction. And what you are getting? Error also you have. What you have? Error also. So suppose x is equal to 1, y is equal to 2, and it's saying that 3, the error is how much? 1. X is equal to 2, y original value is equal to 3, that 5 is there, the error is equal to how much? 2. Now this is 3 is there, now this is 4 is there, and this is 8 is there, the error is how much? 4. Now see, if you take 1 is error, 2 is error, 4 is error. The error is what happened? Every time what happened? Doubling. So that is nothing but errors having what? Relation. Errors having what? Relation. So that you need to avoid. That you need to avoid. That is called autocorrelation. Relation between the errors. Relation between the errors. Autocorrelation. Autocorrelation. To know that autocorrelation about the errors, we have a test called Durbin-Watson test. Durbin-Watson test. Durbin-Watson test. Now Google it, Durbin-Watson test. Tell me explain the formula. Explain the formula. Durbin-Watson test. Explain the formula. Explain the formula. Who will explain in simplest way? What is the formula? Tell me, ma. What is the Darboux-Watson test formula? Summation of error ET minus ET. Okay. Summation from where to where? 2 to T. Divided by summation ET. T equal to 1, na? I know, I know. ET E T minus T minus 1, na? Near T, yeah. ET, yeah. Let this one only. I will write like this. But here ET ET minus ET minus 1. T equal 1 से or 2 से? हाँ, 2 से. This is 1. T equal to 1 to 2 and T equal to 2 2. This is called Darboux-Watson, DW. Capital T. Take T is equal terms, expand it. Expand करो. ये पहले क्या होता? इधर 2. इधर क्या होता? 2 minus 1 क्या होता? 1. This is 2 minus 1 whole square, right? This is 2 minus 1 whole square. And then plus, next what? Next 3. 3 minus 2. Then what you are doing here? Simply you are doing that 4 minus 2 one term and 2 minus 1 another term. Are you getting the logic now? Next term is what? Next term is what? Here E4. Then E3. That's why you are keeping that T equal to what starting? 2. If we keep T equal to 1, then 1 minus 1 what happened? 0 aata. But 0 term is not there. That's why we are keeping E2 minus E1, E3 minus E2, E4 minus E3. First three terms. And what about this term? First term, second term, and third term. It is the first term. It is the second term. It is the third term. First term, second term, third term. This is error 1 square, error 2 square, error 3 square. So all the error 1 square, error 2 square, error 3 square, what is the fancy name for that? RSS, na? That is RSS. It is RSS. That is the fancy term. Simply we are dividing with what happened? Total error. Nothing but a total error, you can say that. Residual sum of square errors or sum of square errors. Technically speaking, both are and below are almost same only. A E1 है तो AB E1 square E1 square E2 square E2 square E3 square E3 square. And next term what happen? Suppose you take this term here, you take this term. Now technically speaking, only look at this. Only look at this. Understand the pattern. Now I am writing this extra. Suppose somewhere now here become what happen? N become here. What will become here? N minus 1. Here what will become? N. That's it. That is N. That's it. That is the term. Technically speaks. Are you following, ma? Can you please confirm the chat? I can easily challenge, ma. 99%, 90% people are doesn't know about Durbin-Watson test. Otherwise, they forget the Durbin-Watson test. Okay. You can ask me any people. Durbin-Watson test is the test per, it is a statistical test per to find the autocorrelation. And this is the formula. DW test. फॉर्मूला करेक्ट बोल दिया और गलत बोल दिया. हाँ, what you have told the formula? हाँ, करेक्ट बोल दिया गलत बोल दिया. पक्का? Then the website is wrong or what? What this done? They taken the differences and they taken the square. Difference करने के बाद square and sum of the differences square. Differences square. This one is correct. This one what you have done? Sum of the differences square. That formula is correct. Formula is correct. Sum of the differences by sum of the square of errors. Then you can take like this. Sum of differences squares. Sum of differences squares. Now we have a ranges will be there. Durbin-Watson test. We have a ranges will be there. Tell me that ranges. 0 to 4. That means total 0 to 4. Total 0 to 4. But the cutoff is 0 to 2 is one cutoff. And 2 and 2 to 4 cutoff. Tell me what is 0 to 2 cutoff means? Positive cutoff how much? 0 to 0 to 2. So you'll 0 to 2 means exactly like 1.999 you can say, okay? 1.99. The positive. 0 to 1.99. What is the negative? Till 4. When is the no correlation then? Exactly 2. Exactly 2. Durbin-Watson test equal to exactly 2. That is equal to no correlation. Interview will be very happy. At least you will say one statistical method. There are statistical methods. Statistical methods. Durbin-Watson test is the one statistical method. There are thousands of statistical methods are there. Formula and these three. 0, 2 to 4. Formula and these three is enough. This formula and this meaning is enough. So VIF, whenever you listen about multicollinearity, you immediately recall what? VIF. And whenever you remember about autocorrelation, you need to remember what? Durbin-Watson test. ठीक है? पक्का question. Okay, you want to write 1,000 times, you will write 1,000 times. I don't mind. These all are pakka questions. Assumptions in linear regression is a pakka question. Uh, 2.001 say. Correct. But so many years I got sick suddenly. I need to analyze myself. Why I don't like this? I didn't remember when I got last time fever. So many years it happened. So many years. After COVID injection, then yeah, vaccine, I got fever. Everyone got fever, no, at the time. Yesterday, I watch one movie, Sravya, Kida Kola. Did you watch that movie? And like one nice joke is there in that. Surrender the bottle. Do you know that joke? Surrender the bottle. I love minimum 10 minutes for that joke. What a joke that is. Surrender the bottle. Lol. Surrender the bottle. Next, fourth one. Errors should follow normal distribution. Error should follow normal distribution. Error should follow normal. First two are related to features. What are first two? What is the first assumption? Linearity. That is related to variables. Second assumption? Multicollinearity. That is also related to variables. Now next three are related to errors. What is the third one? No autocorrelation. What is the fourth one? Errors or follows normal distribution. You know that how to check the normal distribution, that is, you know already that is. But there is a plot called quantile plot, QQ plot. QQ plot. Quantile plot. Quantile plot. QQ plot. Quantile plot. That is very easy, ma. You can easily identify that quantile plot, QQ plot. You see these diagrams. If this line, vertical line is there, right? If a data points also follows on the vertical line, it is a normal distribution. If it is deviated like this, right? It is not follows the normal distribution. Understand the diagram? So QQ plot is a diagram. By seeing the diagram only, you can say that. So it is the QQ plot. It is also follows a normal distribution. So it is a graph between the theoretical quantile and sample quantile. So this is the task for you. You need to explain tomorrow about the QQ plot. Okay. This is a task for you. Task for you. Refer the Khan Academy. Khan Academy. Khan Academy in YouTube. They explain very well. Sample quantile, yeah, observation quantiles. This you need to explain, ma. QQ plot. Quantile plot. So you are coming offline and you are recording my class also. Online. That is. You are doing recordings, right? I know that. Don't sell my recordings to outside. Okay, for 500 rupees. Don't sell that. And the final one, very, very important, is errors follows homoscedasticity. Homoscedasticity. Skedasticity. Why that it is not spedasticity, the skedasticity. Homoscedasticity. Skedasticity. Versus heteroscedasticity. Homoscedasticity, heteroscedasticity. What happened? The population, if you have a population of data, if you have a population of data, the data has 10,000 observations. How many observations? 10,000 observations. You divide into 10 parts. Each part has how many observations? 1K observations. 1K observations. Then we apply we apply linear regression model, then we get the errors. How many errors will get? 1K errors. How many errors? Will get 1K errors. If you plot the distribution, over that 1K observations, you can identify how that variance we can identify, right? Variance we can identify. And that variance should be same for all parts. Again, I'm repeating. Population data, how many observations? 10K. So 10K observation divided on how many parts? 10 parts. So 10 parts means how many observations each? 1K. For each 1K observation, you applied what? Linear regression model. That means how many models you applied? 10. So for every linear regression model, how many errors you will get? 1K. Because 1K observations, right? Every sample you will pass, you will get prediction, you will compare with original, and you will get error. So how many errors you will get? 1K error. So that 1K error, you plot the diagram like this. You plot the diagram for 1K errors. So that 1K errors, it might be plot like this, suppose. Might be plot like this. This is for only one part. And this diagram should be common for all the parts. Everything should become like this only. Everything should become like this only. And this is called homoscedasticity. Equal variance. Homo means same. Homo means what happened? Same. Hetero means different. Homogeneous, heterogeneous, right? That means all the parts of variances, variance distribution should be same. That is called homoscedasticity. Equal variances. Not across all the samples. Again, parts, 10 parts. Each part, the variance should be same. Okay. Now tell me how you are done. Tell me step number 1. How many observations are there? Next, what you have done? 10 parts. You are one part. Kumar is one part. Naidu is one part. For your part, you will get variance distribution, right? For Kumar part also, you will get variance. Naidu part also variance. You all should be equal. That is called homoscedasticity. That means skedasticity means spreading. The spreading should be equal. Homo means same. Skedasticity means spreading. Spreadness. The spreadness, equal spreadness. It should be equal spreadness. Homoscedasticity. It is the equal variances. Homoscedasticity. You see here, this is. It is not equal. It is unusual. See, it is going up and going down like this. That is. It should be equal like this. You see, homoscedasticity. These are equal. What happened? Decreasing, and decreasing. See here like this. Is a equal thing. So that is called homoscedasticity and heteroscedasticity. You will see right. Now this is a equal. See, this is homo. And this is what happened? Hetero. The variance is changing. changing. It is the equal variance. Now you see here, this is same and this is different. So you need to see like this. You should not see like this. I'm copying this. Understood? Homoscedasticity means? Homoscedasticity means same variance, equal variance. Equal variance. So pakka question in this, they will ask you like this. Question number 1. What are the linear regression assumptions they will ask you? Okay. Assumptions. In that second question, they will ask you about the multicollinearity thing. Multicollinearity thing. Multicollinearity. Multicollinearity. Whenever the multicollinearity you discuss, you will definitely talk about VIF. Definitely talk about VIF. And question number 4. The very, very important next thing is called after VIF, Durbin-Watson test. And question number 5, they will ask you about what is homoscedasticity. Homoscedasticity. These 5 questions are very, very important. These 5 questions. These 5 questions are very, very important. We'll solve multiple questions in the linear regression now. We'll test your knowledge now. MCQ on linear regression. Let's see, something is there here. A set of observations independent correspondent given below data coefficient of linear regression a plus bx is estimated as 6.1. Based on the data, the coefficient of linear regression model equal to y is equal to a plus bx is estimated. What is the coefficient of b? Will you solve to this? What is the formula of b? b का फॉर्मूला क्या है? कोएफिशिएंट का फॉर्मूला क्या है? कोवेरिएंस ऑफ x, y by variance of x into, that's it, variance of x, summation of x into minus xi, y into y by summation of x minus xi whole square. So you can able to find that, correct? Tell me, able to find it or not? I'm not asking you to find now, but you'll able to do or not? He's doing, see? I have done the answer. B is the 1.9. Tell me this. In this, what is the linear regression equation? X bar given, y bar given, standard deviation given, standard error given, correlation coefficient given. What is the regression equation? बोलो ना. What is the beta one? This kind of question they will give in the GATE exam. Okay. This kind of question they will give in the GATE exam. You need to solve and you need to put in, no? That is. That only this kind of a question they will give in the GATE exam. No, GATE also implemented data science, right? This is we are not interested. Now this is not interested. But you can able to solve that. This MCQ all mathematics is there, right? No, will not like this. Which of the following represent the classification algorithm? Linear regression is a classification or regression? Then hatao, see hatao. And we actually supposed to learn today logistic regression. So logistic regression is not a regression, it is a classification model. It is a classification model. This MCQ is not good. Okay, we'll do this MCQ. 30 questions. True or false है इधर आया था. Answer A already seen, huh? Tell me. First answer, first question. Linear regression is the supervised machine learning algorithm. True or false? Pakka. What happened in the chat? Don't sleep, ma. True. Very good. Linear regression is mainly used for regression. True or false? True or false? You read only this kind of questions only. Or at least you are saying this answer is correct. It is possible to design linear regression algorithm using a linear neural network. Don't say don't know. Neural network is the boss. Any kind of problem you can create by using linear regression. So neural network. Neural network is a AI model, right? Any kind of problem can solve by AI model. Okay. So true or false? True. Which of the following methods used to find the best fit for data linear regression? Least square method or maximum likelihood method or A and B? Least square method for what? Least square method for what? OLS. Only Priyanka saying remaining all are what you are doing. Maximum likelihood for what? MLE for what? I told you already this. To find the coefficients, we have so many methods. Expression in the linear regression is asking the question is least square method or maximum likelihood method, logarithmic loss. A or B or C or both A and B? Tell me that. Answer is D. Pakka. How many said answer is D? You don't want to raise the hands also? Both A and B. Answer is A only. अरे वो B वाला लॉजिस्टिक रिग्रेशन के लिए I told you right already. OLS for linear regression, maximum likelihood method for logistic, gradient descent for neural network. Tell me this. This you tell. What is the metric we want to use here? Which one? What is the familiar that you know? Bolo that answer, na? That is the only answer. Continuous variable means it is a what number. Number के लिए means remaining all are for classification. Only D is for regression. AUC, ROC, accuracy, log loss, all are for classification metrics. Okay. So out of 5, almost 3 you said correct. Lasso regression can use for variable selection. Okay, we didn't cover, right? Yeah, tell me the blind guess. True. True, true. Which of the following is true bar residuals? Tell me this at least. Lower is better or higher is better? A and B depending on situation. None of this is. Which is better? Residuals. None of this. Residuals. Residual means what? Error should be what? Then why D? Arey, why D? Suppose we have n independent variables. Tell me this. Why the independent variable? Now imagine that you are applying linear regression. Which of the following is true for x1? You find the correlation coefficient is minus 0.95. Tell me the relationship. Weak relationship or strong relationship, neutral or correlation cannot judge the relationship. Good question, no? Tell me. Correlation coefficient 0.95 minus 0.95. Weak relationship or strong relationship? Strong. Strong or weak? Strong in negative case. Strong in negative case. It is strong, but in negative case. But how can we judge that? It is a weak or it is stronger, it is can't judge the relationship. Huh? Why is not output बना होता? होता है ना? Strong. Minus 0.95 is the strong in negative case. Okay, last question. Tell me this. This is also a good question. If V1 increases, then V2 also increases. V1 decreases and V2 behavior is unknown. You and your friend is there. If you are increases, that will also increases. If you decreases, we don't know unknown. Exactly, wife and husband. If we good, wife is also good. If we down, we don't know the expected behavior that. Tell me. Pearson correlation equal to 1, Pearson correlation equal to -1, Pearson correlation equal to 0. अरे 1 है तो क्या 1 होता ना, देन -1 होता तो क्या होता अभी पता नहीं. What will say? Huh? Close to 1. Positive is positive. पक्का that is. No doubt. Negative है तो पता नहीं. Then what you will do? None of the above or A or D? A or D? A or D? D. None of the above. None of the above. Okay, last question. Huh? They're simply saying no. That is, you are increasing your wife is also good happy. If you are decreasing your wife is you don't know the behavior. Because how can you judge the relationship? None of the above. You can't say positive relationship. You can't say negative relationship. That is. Chalo, what is the last one? V1, V2 is 0. V1 and V2 is 0. It is right to conclude V1 and V2 do not have any relationship between them. That means V1, V2 correlation equal to 0. Suppose V1 and V2 is 0, but it concludes that V1 and V2 do not have any relationship between them. That is false. We can't conclude directly the judgment. That is. V1, V2 increases. That is the above case, right? That is the above case. V1 increases, V2 also increases. V1 decreases, V2 behavior doesn't know. That is. Based on the above case, that is. At least you are saying some answer. At least you are thinking. That means you learned something. At least you learned something. Whether you say correct or wrong, I don't mind. But at least you are trying to do something means you learned something, right? Enough. I'm happy for that. I'm happy for that. Try to solve this kind of questions, interview questions. Then because already one algorithm is over. And tomorrow is also we will start logistic regression. So try to solve the questions now. Okay. And today online people are not at all responded. Very, very bad that is. I don't know what they are doing. Anything important काम चल रहा है क्या online में? Thank you so much. See you tomorrow.